So exponential notation. We've all seen this before, like a to the n. So this is called the base, and it is what the factors are. Remember that factors are things that are multiplied. And then this is called the exponent. It is how many factors there are. And so a to the n is equal to 1 times n factors of a. I always think of there being that factor of 1 there because it helps us when we start talking about negative exponents and exponents of 0, remembering that even though we don't see that coefficient of 1, there's really a factor of 1 inherent in any multiplication problem that we do. Just like when we are simplifying fractions, if we cancel everything, we end up with 1, not 0, because something divided by itself is 1, right? So there's always that factor of 1 when we're dealing with multiplication and division. So just a couple of examples. Let's see, so 4 to the third, we would think of as 1 times 3 factors of 4. A couple kind of funny ones. We have negative x to the 4th. So that x to the 4th is 1 times 4 factors of x, right? So this is that negative sign, then 1 times 4 factors of x. Note here that the base is x, it's not negative x, because the exponent applies only to the factor that is directly to the left of it. The only way for it to apply to more than one thing is for that base to be in parentheses so that all of those factors are grouped as part of the base. So if we have negative 3x squared, that's negative 3 times 2 factors of x. I usually drop that factor of 1 if there's a different coefficient there. I mean, we could put another factor of 1, but if we have another coefficient there, the whole reason we have that factor of 1 is so that we have some sort of a numerical coefficient. So if we have a coefficient of negative 3, we don't necessarily need the factor of 1. Whereas if this guy's in parentheses, now my base, so in the previous example, my base of the exponential expression was x, right? So there were 2 factors of x. Now my base is negative 3x because I've grouped that in parentheses. That shows that that entire thing is my base. And so I have 2 factors of negative 3x. So negative 3x times negative 3x. And I'm not simplifying any of these right now because we're really just concerned with the definition of what it means to have an exponential expression as opposed to like what it actually equals, because all of our rules follow directly from that definition of exponents as repeated multiplication. So everything that we do today, it's a lot to keep track of if you're trying to just memorize like rules. But if you can remember where they all come from with respect to that definition of exponents as just repeated multiplication, they're all pretty straightforward, like following that definition. I think it's easier to think of them that way than to try to like memorize them, because as you're about to see, like they're all really similar and the names of them are all really, really similar. And so it's hard to try to like just memorize them like by rote. Let's talk about x to the 0. Anybody know what x to the 0 power is equal to? 1. 1, very good. So, and the reason for that is that
It's always 1, isn't it?
it is. Well, anything to the 0 power is 1, yes. So the reason for that is because of that factor of 1, right? If I have x squared, that is 1 times 2 factors of x. Hey, wake up.
So if it was like
You know.
5 to the 0, then
Yes,
it would still be 1?
it would be 1. Yep. Because in this case, like x just represents some number. So if we put 5 in for x, we should get the same exact thing as if we put 2 in for x, or 9 in for x, or a in for x, or z in for x, right? Because x is just some arbitrary number, which means like we have to get the same thing no matter what x is. Does that make sense?
And say you put the exponent inside the parentheses, would that be the same rule as if you were doing 4 to the 3rd power?
Ooh, great question. Let's finish on this 0 exponent and then let's readdress that. So then x to the first is 1 times 1 factor of x. Oh, I didn't finish this sentence. There we go. And so x to the 0 should be 1 times 0 factors of x. So the 0 in this case isn't like I'm multiplying by the number 0. It's that I'm writing a factor of 1 and then I'm not writing any more factors. Right? There aren't any more factors in that expression. So the only thing here is a 1. That's the only factor in the expression. So the key with exponents is to not think of them as numbers per se, but to think of them as like counters. So all they're doing is counting how many factors we have. So even though we see a 0 and it's tempting to be like, oh, anytime you multiply by 0, you get 0. It's not like the number 0. We don't have a factor of 0. It's just saying I don't have any factors of x. So this is like 1 times nothing else, which just gives me 1. I'll show you another way that we can think of the 0 exponent after we do our quotient rule, because there's another way we can see that. So, Stefan, you were asking if you have like 4 squared like this.
Yeah, is it the same rule as if it was like 4 to the 3rd or something?
Yeah, so this is actually exactly the same as that, because those exponents aren't actually grouping anything. Or sorry, those parentheses aren't actually grouping anything. I'm trying to think. If you, like, where the difference comes in is if you have, like, if you have 3 times 4 squared, as opposed to 3 times 4 squared.
Oh, yeah, okay.
Right, so the parentheses, they group multiple factors in the base, and so it really only changes anything if the exponent is outside the parentheses. Other questions? So what if I had like that? What would that be equal to?
1.
Negative 1.
Be negative 1, right? Because it is the negative sign and then 1 times 0 factors of x. So when we say anything to the 0 power is 1, it's true, but we have to be careful about what our base actually is. Again, just like when we did that negative x to the 4th up here, our base is just x. So that's what's being raised to the 0 power. That negative sign isn't part of our base.
What if the negative x is in parentheses?
Great question. So this is everybody's favorite problem. It's so if the base is grouped, if there's nothing outside the base, then everything is being raised to the 0. And so we just get 1. So it's all about like what that base is, so what the factors are. If you had just, even just this.
So it's treated like an
Yes, 0 is an even number. But you just want to think of like what's happening inside the base and what's happening outside the base. So what factors you're actually applying the exponent to and what factors you're not. We can think of that negative sign as a factor of -1. Right? And so that exponent of 0 doesn't apply to that factor of -1 there. Whereas here it does because it's in the parentheses. So I have 0 factors of -1 and 0 factors of x, as opposed to 2 lines up from that, I have 1 factor of -1 and then 0 factors of x.
So then if it was -1 with the 0 in the parentheses, then it would be -1.
Yeah.
Okay.
So if it was like this, again, those parentheses aren't doing anything
Okay.
because there's nothing happening outside of them. So they're not actually grouping anything.
Okay.
Other questions on this? So we're going to start maybe on like a separate sheet of paper so you can continually add to it. Although I did do a handout, so you guys will have it all in one place eventually. But let's just write a list of our rules. So exponent rules. So an exponent of 0 anything raised, I shouldn't do x, I'll do a. Anything to the 0 power is just 1. So then let's get into our multiplication rules. So we sort of have like 2 types of rules when it comes to exponents. We have ones dealing with multiplying exponential expressions and ones dealing with dividing exponential expressions. So we'll start with the multiplication rules. So first, we want to see what happens when we multiply exponential expressions. So if I have like x squared times x to the third, notice that this is all really just multiplication, because x squared is just multiplying 2 factors of x, and x to the third is multiplying 3 factors of x. So if I take 2 factors of x and I multiply by another 3 factors of x, I have a total of 5 factors of x. Which is x to the 5th. And again, we want to think of this as think of our exponents as counters. So it's just counting how many factors I have. So if I have 2 factors and then I have another 3 factors, then I'm going to end up with 5 factors. There's no way to get 6 factors of x from this, right? So again, thinking of those exponents as counters, not actually numbers that we're doing the operation with. So our product rule says if I have a to the n and I multiply it by a to the m, well, I have n factors of a plus another m factors of a. So my new exponent can be obtained by adding the 2 exponents. Now, of course, this only works if the bases are the same, because those counters have to be counting the same factors. If I had like 2 to the 5th times 3 squared, well, I have 5 factors of 2, and I have 2 factors of 3, but I don't have 7 factors of anything, right? You guys see what I mean? So that just simply can't be simplified other than just multiplying it out and getting a big, huge number. But in terms of exponent rules, we can't simplify that because the bases aren't the same. So we have some rules for when the bases are the same. We have some rules for when the exponents are the same. But if they're both different, there's nothing we can do in terms of manipulating the exponential expressions that will allow us to simplify that. So like if I have a to the third times b to the 5th, that cannot be simplified. Because again, we don't have 8 factors of anything. That makes sense. Stop me if you have questions. Let's see. So, if I have 4x to the 5th times 9x to the 3rd. So notice that the only operation going on here is multiplication. We have several different ways of writing multiplication, so sometimes it looks like they're different operations, but this is really just 4 times x to the 5th times 9 times x to the 3rd. And because multiplication is commutative, which means that the order that you do it in doesn't matter, then we can say this is 4 times 9 times x to the 5th times x to the 3rd. So we have 36, and then we have 8 factors of x. So 36x to the 8th. So same thing if I wrote it as 4x to the 5th times 9x to the 3rd. That's an identical problem. I mean, like, those two problems are the same. Again, because we have different ways of writing multiplication, sometimes it can look like they're different problems, but those two problems are identical. This is exactly the same thing as that. So be careful, especially when there's parentheses involved. A lot of people have the misconception that when you see parentheses, it means something about distributing. But the distributive property relates multiplication with addition and subtraction. So if there's no addition or subtraction in the parentheses, then the distributive property doesn't apply. So just because we have parentheses here doesn't mean that we're doing any sort of funky distributing. It's just if there's addition or subtraction that we distribute multiplication. Here it's just another way of writing multiplication, so of just grouping factors. So let's talk if I have like x to the 3rd to the 4th power. So raising an exponential expression to another exponent. So this is just repeated multiplication. So if I have x to the 3rd to the 4th, that's saying I have 4 factors of x to the 3rd. So that's x to the 3rd times x to the 3rd times x to the 3rd times x to the 3rd. Well, that's just using the product rule repeatedly, right? So if I have 3 factors of x and another 3 factors and another 3 factors and another 3 factors, how many factors of x do I have? 12, which we get by, again, using that product rule repeatedly. So I'm adding up all those factors. Sorry, my Bluetooth is lagging today. It's making things messy. What's another word for repeated addition?
Scientific notation. Oh,
I promise it's something you've seen a billion times. When you add something to itself repeatedly. Yeah, it's just multiplication. So in fact, the relationship between multiplication and exponents is identical to the relationship between addition and multiplication. So exponents represent repeated multiplication, and multiplication represents repeated addition. So if I add 4 terms that are the same, it's the same as multiplying that term by 4. So this is the same as x. To the 4 times 3. That's 3 to the 4th. 4 times 3 is 12. X to the 12th, which leads us to our next rule, which is called the power rule. Which says that a to the n to the m power is a to the n times m. So we're going to do a few of these. Does everybody have that written down? Let's see if this needs like a little bit of juice. We're going to do a few of these before we move on to the rules having to do with addition. So let's do...
So now, back to that
Yes.
one, the
Yeah.
N and M.
Yep.
You don't have to put any signs or anything in between? Because,
So just like 2x is 2 times x.
right.
So a to the n(m) is a to the n times m. There's multiplying the exponents. So I want you to simplify these 4 expressions. Oh, let's do one more. We have the product rule, we have the power rule, and then we have the power of a product rule. Which says that if my base has multiple factors, well, that's just the same as having n factors of A and also n factors of B, right? If you imagine lining up, so just like on number 2 here, that's 5 factors of negative 2x, which gives me 5 factors of negative 2 and 5 factors of x, because of the commutative property. So this is really all just multiplication, right? You could put a dot in between all of these. And so we can rearrange those factors to say that this is like negative 2 times 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 x times x times x times x times x, which gives me just that 5 factors of -2, and then 5 factors of x. So, I don't want an equal sign right there. A to the n, b to the n. So if I have multiple factors raised to a single exponent, I can apply that exponent to all of the factors. We have to be really careful about when we can use this and when we can't. So notice that the operation inside the parentheses here is multiplication. If the operation is anything other than multiplication, then the rule doesn't apply. So we call this the freshman's dream, that x plus 5 squared is equal to x squared plus 5 squared. That's simply not true. And the reason that that's not true is if we go back to, like if I have 2x to the third, if I write that out using the definition of exponents, how many operations? So the operations we have to work with here are multiplication, division, addition, and subtraction. On the right side of that equal sign, how many operations are there? There's just one, right? That is all multiplication. And because it's all multiplication, I can rearrange my factors. I can say, okay, this is really just 2 or 3 factors of 2 and 3 factors of x. All I have to do is rearrange them. And I can do that because it is all multiplication. And so it's okay for me to write it like this. However, if I have 2 plus x to the third, again, if I write that out using the definition of exponents as repeated multiplication, that would be 2 plus x times 2 plus x times 2 plus x. How many operations are in that expression? There's 2, right? There's multiplication and there's addition, which means I can't just start rearranging things because there's still the distributive property that would have to come into play here, right? Because I'm still working with both multiplication and addition. The reason that this rule works is because in reality, the only operation going on here is multiplication. And I can rearrange factors all I want when I just have a bunch of factors lined up. But if there's an operation other than multiplication going on, then that's not true. I can't just start I can't separate the 2's and the x's because they're being grouped still by those parentheses. Does that make sense? And so this is not the same as 2 to the third plus x to the third. That's everybody's like favorite mistake to make because we really want it to be true. It would make so many things work out nicely if it actually worked, but it doesn't, unfortunately. So remember how I said that the relationship between multiplication and exponents is like exactly the same as the relationship between addition and multiplication. So this is where like the distributive property comes from, is if I do 3 times 2 plus x, that's saying that I am adding 2 plus x to itself 3 times, which is 2 plus x plus 2 plus x plus 2 plus x. And again, all of a sudden, I only have one operation. And because addition is also commutative, I can rearrange those terms into 2 plus 2 plus 2 plus x plus x plus x. And that's where we get the distributive property. Because the relationship between multiplication right here and addition inside the parentheses works the same as that relationship between multiplication inside the parentheses and exponents outside of it. This is where things get hairy and nothing works the way we want it to. That make sense? It's pretty cool, right? Super exciting.
Love that.
I guess let's talk division. So we've done everything we can with multiplication. So we've multiplied exponential expressions, we've raised exponential expressions to another exponent, and then we've multiplied and raised to another exponent. Now let's talk dividing. So if I have x to the 5th divided by x squared, so think about how we simplify simplify fractions, right? We do prime factorization of the numerator and denominator. So that would be 5 factors of x divided by 2 factors of x. And x divided by x is just 1, so we can cancel common factors. So we have reduced the number of factors in the numerator by 2, which makes it 3. And we've reduced the number of factors in the denominator by 2, which means we now have 0 factors of x. So we just get 1. And so we get x to the 3rd. So if we think of always reducing the number of factors in both the numerator and denominator by however many factors are in the denominator, then that denominator is always going to end up being 1. And the numerator is always just going to be whatever the exponent in the numerator is minus whatever the exponent in the denominator is. So that leads us to our quotient rule. So I have x to the n over x to the m. So in the denominator, if I cancel out m factors of x, all the factors of x are gone in the denominator. And then in the numerator, I have x to the n minus m. The result of the quotient rule always goes in the numerator. Always, no matter what the sign is. So if we have, say, two b to the 4th divided by 10b. So we can separate this, again, just like we did when we were multiplying, right? We could separate the coefficient from the exponential part of it. So this is like 2 over 10 times b to the 4th over b. So 2/10 is just 1/5. And then how many factors of b do I have?
In total 5. Or 4, you take away 1, so 3.
Right, so 3 in the numerator, right? So that's b to the 4 minus 1. So b to the 3rd over 5. We don't have any factors of b in the denominator because we canceled them all.
Do you have to do all those steps?
No, you can go straight to b to the 3rd over 5. But it's one of those things, again, when people ask, like, do you have to do all those steps? Like, the answer is really yes, but half of them you're visualizing in your head. Like, it's not that you skip them. It's that you, just like lining up all the factors of x, we're not skipping that step. We're visualizing it and generalizing it. So it's people talk about doing math in their head a lot, and half the people who say it mean they're just like skipping stuff. But really, when you do math in your head, you want to actually like see it in your head, because that's how you avoid making mistakes, by trying to generalize things that aren't actually generalizable. I don't know if that's a word, but does that make sense? Like, you want to see all, like, when I do this, like I see what we have on that in the first step, like the canceling and stuff, to get to b to the third over 5 in a single step. But that way we don't make mistakes with like where they end up and things like that. So if I have, oh, let's write the quotient. Did I already write it? Yes, I did. So suppose I have this, x to the third divided by x to the fifth. What should that be equal to? Okay, so I hear a 1 over x squared, which is true, because if I have 3 factors of x, and then I have 5 factors of x, three of them cancel, and I end up with 2 factors of x on the bottom. Totally true. However, we also just learned the quotient rule, which said that if you divide 2 exponential expressions that have the same base, then that's got to be equal to x to the 3 minus 5, which is x to the negative 2. Yeah? So this leads us to our negative exponent rule. If we use 2 techniques that are both totally valid, then they both have to produce the same result, which we just did. The quotient rule is totally legal, and writing out factors and canceling is also totally legal, which means the only possibility is that these 2 things are equal to one another. So 1 over x to the second is equal to x to the negative 2. So this is not super intuitive that these are the same, but let's go back again to the definition of exponents and just look at a pattern here. So x squared, we said, is 1 times 2 factors of x. X to the first, we said, is 1 times 1 factor of x. X to the 0, we said, is 1 times 0 factors of x. So if we keep going, we have x to the negative 1, which should be 1 times negative 1 factors of x, which makes absolutely no sense, right? You can't count a negative number of things. So instead of thinking of that as a negative 1, let's think of it as like an opposite sign. So what is the opposite of multiplying by 1 factor of x? Dividing, right? So instead of doing 1 times 1 factor of x, I'm going to do the opposite of multiplying by a factor of x, which is dividing by a factor of x. So this is 1 divided by 1 factor of x. Which is 1 over a factor of x. So x to the negative 2 should be 1 divided by 2 factors of x. So 1 over x squared. So a negative exponent, again, when we think of these exponents as counters, that negative sign really just means do the opposite of repeated multiplication, which is repeated division. So every time we have a negative exponent, that is saying take the reciprocal of the base. So our negative exponent rule.
So you're saying just flip it but make it positive?
Mm-hmm.
Okay.
So pretty much if it's on the bottom, it's negative.
No.
If it's on top.
Neither. You want to be really careful with the whole, like, if it's here it goes, or if it's positive or negative it goes here or there, because it's not that negative exponents go on the bottom and positive exponents go on the top. It's that negative exponents mean take the reciprocal of the base, and positive exponents mean don't take the reciprocal of the base. So it depends on where it is, like where it started. If it's on the bottom and it's a negative exponent, taking the reciprocal will put it on the top. So when we write this, it's a little bit misleading because we write this. I switched from A's to X's, but I guess it doesn't really matter. Which gives people the impression that like every time you see a negative exponent, you are going to end up with something with a fraction with a 1 on top, which isn't actually the case. What this really means, when we put 1 over something, what it really means is the reciprocal. So x to the negative n equals the reciprocal of x to the positive n.
So if you didn't have the 1 above it, then it would be a positive, right? X n. So the 1 makes it.
If the 1 wasn't there, then it would be x to the n over 1.
Right, which would make it positive.
Well, I mean, it's a positive either way. That is at 1 over x to the positive n. If you have 1 over x to the negative 5, that is the reciprocal of 1 over x to the 5th. So that's just x to the 5th. Right? You take the reciprocal of it, and then that changes the sign of the exponent. Right? The opposite of dividing by 5 factors of x is multiplying by 5 factors of x. So we end up multiplying by 5 factors of x. If I have 2/3 to the negative 7th, well, that is the reciprocal of 2/3, which is 3/2 to the positive 7th. Because when I raise 2/3 to the negative 7th, that's saying divide by 2 7 times. And divide by 1/3, which is the same as multiplying by 3 7 times. So the 3 ends up on top, the 2 ends up on the bottom. In practice, the way that I deal with this is if I have, let's say, 4x to the negative 5th y over a to the 3rd b to the negative 6th. So if I want to simplify that, I always start just with like one big fraction bar. So like just draw like one big line and then go through factor by factor. That 4, does it have a positive exponent or a negative exponent?
Negative. Oh no,
it's positive because that's really 4 to the 1st power, right? So that 4 stays put. But then x to the negative 5 is dividing by 5 factors of x. So he comes down here. Right, so this is where that whole like 1 over thing kind of falls apart. Like, I don't want to write like 1 over x to the 5th within that fraction. That would just give me like a really messy like fraction within a fraction. So I'm saying that when I do 4 times x to the negative 5th, that is the same as 4 divided by x to the positive 5th. You guys see it?
So if it's a negative, if it has a negative, you just flip it. If it doesn't have a negative,
exactly.
You just keep it the same.
Yep. One of my colleagues uses the analogy like if you like own an apartment building and like somebody has a negative attitude, then you make them move like apartments, and if they have a positive attitude, they get to stay where they are. So like if it's a negative exponent, it moves, and if it's a positive exponent, it stays. So y to the 1st power, that has an exponent of positive 1. So it stays where it is. And then in the denominator, I have a to the 3rd, which would stay where it is, because that is multiplying by 3 factors of a in the denominator.
And then the b would move.
Mm-hmm.
Okay.
And then I have b to the negative 6th, that is doing the opposite
Right,
So
keep,
b to the
keep my
6th.
mentality of what I just said. Is there any reason where that would not work?
No,
Okay, easy enough, okay.
that is always true. Because really, like, if we were to write this out in words, this is like 4 divided by 5 factors of x. Times 1 factor of y. Divided by 3 factors of a. Divided by 6 factors of 1 over b. And dividing by 6 factors of 1 over b, that's the same as multiplying by 6 factors of just b. Questions?
So in that case, like the x minus 5, what if you just had a 0? You can't put a, see, the x would change to just a 1?
I don't, what do you mean? Like if
Well,
it's
instead of
instead of
-5, what
the,
if you just had 0?
He's saying 4x
Yeah.
to the negative 0, y.
So
yeah, so
you
that-
said, I mean, normally that changes to 1.
It
Wouldn't
still
you just
changes to
omit it
1.
From the,
uh-huh.
Then it wouldn't move.
so it goes bye-bye. You
I
wouldn't-
mean, it doesn't go bye-bye. You do 4 times 1, which is
Yeah,
4,
Yeah.
right?
But I mean, you
So,
wouldn't have to write the x out.
correct.
then. That's why I meant go bye-bye.
Yep.
Okay.
So you just want to think of it factor by factor. And this is where like this whole thing comes into play. We have to think of numbers and exponents as different things. So if I have, let's say, negative 2x to the 5th, y to the negative 3rd, all raised to the negative 4th power. So I'm going to start by using this rule, which says that every factor inside the parentheses is raised to the exponent outside the parentheses. You guys cool with that? So the first factor is negative 2. That goes to the negative 4th power. And then my second factor is x to the 5th. Raise that to the negative 4th. And my third factor is y to the negative 3rd, which goes to the negative 4th power. So negative 2 to the negative 4th. So when I see these negative exponents, well, actually, let's simplify a little bit more from here before we do that. Leave that guy alone. X to the 5th to the negative 4th, that is x raised to what power? What do we do with the exponents when we raise an exponential expression to another exponent?
Multiply?
We multiply them, so I should get x to the negative 20, y to the positive 12. Very good. So now we're going to go through factor by factor and put everybody in their place. So one big line. Negative 2 has a positive exponent or a negative exponent?
Oh, which one?
That negative 2.
Negative.
It has a negative exponent, which means it comes down to the denominator. The base stays the same. That's the number negative 2. So when I have negative 2 to the negative 4th power, that is saying take 1 and divide it by 4 factors of negative 2. If that negative 2 was an x, would you be okay with it? So x to the negative 4th, you're okay with that being 1 over x to the 4th? Well, I mean, negative 2 is just a number, right? just like x. So like, why would it be any different? You take your base and you raise it, you divide by it 4 times. But if you don't have those parentheses, then it changes everything, right? And then x to the negative 20th, we have a negative exponent, so that's dividing by 20 factors of x. So down here, and then y to the 12th. Because that has a positive exponent, so it stays on the top.
So the base really doesn't matter, it's what the exponent is, a negative or
Well,
a
I mean,
positive.
the base matters.
Well, not as far as where you put it.
Right.
Top and
The
bottom.
most common error is that people just want to like go to an like, especially with the numerical bases, people want to make a number really fast. I don't care about what number you get when you multiply -2 by itself 4 times. Treat it just like it was a variable, because otherwise you're going to end up with like, oh, a negative and a negative is a positive type deal, which isn't how it works, because a negative exponent doesn't mean the same thing as a negative base. A negative exponent means do division instead of multiplication. A negative base is a negative number, right? Like the thing that you're multiplying is a negative. Whereas when we have a negative in the exponent, it doesn't mean that we're going to get a negative number, right? Like 4 to the negative 3rd, is that a negative number?
Yeah.
It is not, because it is
3 times.
1 divided by 3 factors of positive 4, right?
So the only thing
That
how do you
it's not a
distinguish-
negative, it's an opposite. What?
So then how do you distinguish when you need to do that? Because in the beginning of the lesson, we just multiplied across.
Right, because in the beginning, all of our exponents were positive. A positive
one
exponent
negative.
means
So it's-
multiply
okay,
by
okay,
that many
okay,
factors.
okay. That- I was like,
And
what are you
negative
doing? Okay.
exponents
That
means
makes sense.
divide by that many
So as
factors.
long as it's a negative, then you do that. If it's a positive, then you don't do that, and you just stay with
Right,
it. Okay.
so this right here is
Okay,
really a
okay.
division
Okay,
sign.
that makes sense now. I just didn't know how we jumped from that to this right away. Okay, never mind.
So it's sort of like the 0 exponent rule. The only way to get 0 through multiplication is to multiply by a factor of 0. And so if I have x to the 0 power, there's no way I can ever get 0, because the only factors that exist are 1 and x, neither of which is 0.
Well,
So
I think
this,
the throw off was normally, like you said, we were looking at positive exponent, and then like a -4 to the 3rd power would be a negative.
right, because the base is
Because the
negative.
base is the
The
negative.
only way to get a negative through exponent or through multiplication
Yeah,
is
okay.
to multiply by a
Right,
negative
yeah,
number,
yeah.
right? And if the base is positive, we're always multiplying positive factors, right? Whereas with that -2 to the negative 4th, we are dividing negative factors.
So,
We're div-
so say that was a positive 4, but that was still a negative base, -2. Then you would just go across.
Yeah,
Okay,
so
yeah, okay.
so -2 to the 4th, that is 4
Yeah.
factors. That's multiplying
Which
by
is
-2
positive.
4 times.
Okay.
But whether or not it's positive or negative, like, I wouldn't worry about at this point. Like, what I want you guys to do is to treat even that -2 as if it's like an A or an X or a B, because the biggest mistake that people make is like trying really hard to get to like a number. And that's where you end up with like a positive 16 on the top, because you're like, oh, 2 to the 4th is 16 and a negative is a positive, right? We have to separate the way we think about exponents and the way we think about bases, because one of them is factors and one of them is a counter. And so you can't be like a negative and a negative, because those two negative sign means different things, right? Like one of them means a negative number, one of them means do division. Right? So putting those together doesn't equal a positive number multiplied a bunch of times. And so it's really like you really just have to adjust the way that you think about these things, because those exponents don't behave the way numbers do, per se, even though they look like numbers. So there's one other rule, which is probably the most boring of all the rules, but we'll write it down. It's the power of a quotient rule. which just says that if you have division inside your base and you raise that to some exponent, well, if you imagine lining up a over b times a over b times a over b a bunch of times, well, you're just going to end up with n factors of a on the top and n factors of b on the bottom, right? Can you guys see it? And which is somewhat intuitive. I told you guys I'd show you one more way that we can see the exponent of 0 rule now that we have the quotient rule.
So say that was AB over CD. It would be A to the N, B to the N, C to the N, and D to the over. Okay.
Because of the parentheses, everything.
Yep, everything to the n power. Okay, so if I have x to the 5th divided by x to the 5th, what is that equal to? 1. The quotient rule says that it is equal to what? So the quotient rule says dividing exponential expressions with the same base. What do you do with your exponents?
That would be 0. Well, can't be 0.
Because you subtract the exponents, right?
Right.
And then be 1 anyway.
So it is 0. Oh,
So
because
x to the 0 has to be 1, because if you cancel off all the factors of x, you end up with 1, right? Something divided by itself is always equal to 1, which is the same as just canceling off all those factors and having a bunch of factors of 1. So again, it's one of those things where like we see the number 0 and we sort of are programmed to be like, oh, it's 0, but we have to think of it in a different way because it's not a number, it's just a counter. Yes?
Yeah, is that the same? X to the 0 would be the same as just x?
No.
So
X,
that would be different.
so x is x to the first power. Because if you write x, you have one factor of x.
Factor.
Here
So
we
we're
have
talking-
no factors of
Right,
x.
okay. So yeah, so if you wrote just x, that would mean something.
That would
put
mean
the
x
0
to the
if-
first.
If that's the case with
Mhm.
the exponent.
Yep. Other questions? So, those are all of our rules, and I've got a handy dandy handout for you. Probably one of the hardest things with simplifying exponential expressions is figuring out where to start and when you're done. So if you look at the bottom half of this half sheet, there's 4 questions. If you're not sure where to start, just start by asking yourself one of these questions. If the answer is yes, then you use one of your rules to simplify. Once you go down the list and the answer to all the questions is no, that's when you know you're done. So let's go through that process a few times to see how it works. Let's simplify. (3x to the 3rd, y to the -4th to the -2 times 2x, make that -2x to the -5th, y to the -3rd to the 4th. So if I start with my questions, I'm like, are there parentheses? There are parentheses, so that's where we use the power rule or the power of a product or quotient rule. So in this case, I need to apply the exponent of -2 to all 3 factors inside those parentheses. So I've got 3 to the -2. I've got x to the 3rd to the -2, which is x to what power?
What is it equal?
So if I raise x to the 3rd to the -2 power, I get x to the -6, yep. And then y to the -4th to the -2 is y to the +8th. right? So raising an exponential expression to another exponent, we just multiply those exponents. Notice we did not multiply 3 times negative 2 because that 3 isn't an exponent, right? So, like, do you guys see the difference between having a base of 3 and having an exponent of 3? So then that second set of parentheses also has 3 factors, and each of those 3 factors we're raising to the 4th. So negative 2, it's a negative number, and so it goes in parentheses to the 4th power. X to the negative 5th to the 4th is x to the negative 20th. Y to the negative 3rd to the 4th is y to the negative 12th. So that first question, are there parentheses? The only parentheses you should end up with are parentheses around negative bases, right? So there's no multiplication inside the parentheses that I have there. So they're okay. They're just around a negative number. So far, so good? Stop me if you have a question, because there's no point in us going on if we're not sure how we got where we are. We good? So now I'm going to go through and say, let's see, is there a product or quotient of exponential expressions with the same base? So there is a product of 2 exponential expressions with a base of x, right? So that's where I use my product rule. I'm going to add those exponents. So we've got 3 to the negative 2, x to the negative 26th. And then I also have a product of exponential expressions with a base of y. So that's y to the negative 4th. Everything you know about adding and subtracting negative numbers is still exactly the same when you add and subtract exponents. And then we have negative 2 to the 4th power. I don't like the way I wrote that. Our next question is, are there negative exponents? Some of my exponents are negative, which means I have to take care of that because my final answer should only have positive exponents. This is where we draw that line and we go through factor by factor. So my first factor, 3 to the negative 2, I have a negative exponent, so that means that comes down to the denominator to change it to a positive exponent. So this is 3 squared. Notice that I do not care even a tiny bit that is equal to 9. The most common mistake is to try to make that into a number too soon. Treat that 3 like an A or a B or a C or an X or a Y. It doesn't matter that 3 squared is equal to 9, because that's where people jump to that so quickly, like they want to do it in the first step, and that's where you make mistakes with the negative exponents. So then we have x to the negative 26th, which brings that down to the denominator. That's x to the 26th in the denominator. And same with that factor of y. I'm going to have y to the positive 4th in the denominator. Negative 2 to the 4th, does it have a positive exponent or a negative exponent?
Positive.
Positive, so it stays on the top. Negative 2 to the 4th. If you are really, really, really attached to actually multiplying that out, you may do it now that the answer to all 4 of my questions is no. Do not do it before that, or you will make a sign error, I promise. If, like, my general rule as far as evaluating things like 3 squared and negative 2 to the 4th is if you know what it is in your head, go ahead and evaluate it. If you have to multiply it out by hand, leave it in exponential form. These numbers, I mean, you guys have heard the term growing exponentially. It means things get really big really fast. So there comes a point when, like, you get to like 5 to the 4th or 5 to the 5th, where like the number is so big that there's no point in actually multiplying it out. Like, it's more concise to leave it in exponential form. In this case, if you were really attached to it, you could write this as 16 over 9x to the 26th y to the 4th. I would be perfectly happy for this to be the answer you gave me on a test.
Okay.
Like, people are really attached to this. I am not attached to it because what I'm testing you on here is exponent rules, not how well you can multiply 3 times 3. Like, I could care less. Because next semester you'll have a calculator and you go 3 times 3. But a calculator will not manipulate exponents for you as soon as the base is x, right? So that's what we care about, is that we understand what these rules mean in terms of like manipulating these operations. So I don't really care if you know what 3 times 3 is. I mean, I do. I'm proud of you for knowing that it's 9.
0.
But really, if you do that last step, you just open yourself up for the possibility of making like a really silly mistake that you don't really mean to make.
Yeah, put an 8 instead of 16.
So last summer, I had like 2 students that like religiously said that 7 plus 5 was 13 over and over, and you guys all furrow your brows, but 2 of you did it on the test, that 7 plus 5 was 13, like already. It's so funny. And I'm not like, it's not funny because it's like stupid or anything. It's just funny because like everybody makes the same mistake with 7 plus 5. And I mean, I know that everybody knows that like you can all figure out what 7 plus 5 is, but it's just one of those things, like you get going really fast and like get something stuck in your head. But I laughed when I was grading because it was a big joke last summer. Like for the entire 8 weeks, these 2 people just like kept on making that like just silly mistake. And if they stopped to think about it for a second, of course they'd get it right. But then I was grading your guys' test and like the same thing happened. So yeah, I don't take points off for silly stuff like that. I don't really care what 7 plus 5 is. I mean, if it really mattered, you would get it right. You know, like if you weren't so focused on like trying to solve an equation, like you'd get it. But I care more about like the algebra than I do about like, you can count on your fingers and figure it out if you really had to. Okay, let's do a few more of these guys. Okay, first thing I want to point out is, everybody see the negative a? Actually, I should change this. This is not going to demonstrate my point even a little bit. There we go. That's a -2. Does it look like a -2? So notice that the exponent on the a is -2, which is also being raised to the 3rd power. But the negative sign in front of the a, the exponent of -2 does not apply to that. However, the exponent of 3 does. And so I can't think of this as this. And I also can't think of it as this, right? Like the 3 has to apply to the negative and the a to the -2, but the -2 only gets to apply to the a. The point being that I can't group the negative sign and the a together because they have different exponents, right? Both exponents apply to one of those factors and only one of the exponents applies to the other one. And so when you see a negative sign that is not attached to a number, the first thing you're going to do is make it a factor of -1. Because then we get to treat it like a negative, like just like we treated this 3 right here. So that's what a negative sign means. Like when you have, we did it back. We did it back here too, right? When we saw that negative, we were like, oh, that's a factor of -1. And down here, when we had x to the 0, or sorry, negative x to the 0, we said that's -1 times x to the 0. So every time you see this negative, make that a little too small. The first thing we're going to do is rewrite this as -1, a to the -2, b to the 5th, over c to the -4th, to the 3rd, times a to the -3rd, c to the 4th, over. Here, that negative sign is actually attached to the number 3, so this is a coefficient of -3 and b squared. No matter how many times you roll your eyes at the fact that I want you to do that, it will not change the fact that your answers will be different if you don't make that a factor of -1. It seems like a very small thing, but it ends up being a very big thing, I promise. What's up, Mike?
Oh, so you don't, if it's positive, like, because the second one, you have an A up front, but it's because it's positive.
Right, it's got a coefficient of +1, and +1 raised to any power is the same. And so we don't have to worry about that coefficient. So now we're going to go through factor by factor and apply the exponent on the outside of the parentheses to each of the factors on the inside. So we're doing that first question, are there parentheses? We're dealing with that right now. So I want -1 to the 3rd power. If you wrote this and you think that you wrote the same thing as me, you're wrong. You did not write the same thing as me because I put parentheses around the -1, right? And they matter. I know it's really annoying, but you guys have no idea how many times I have to write those parentheses when I'm grading your papers over and over and over again. And it means something different, I promise. This is why I cuss like the 3rd time I say it, because it really for real means something different. Like I really, really mean it. Okay, so a to the -2 to the 3rd power, that's a to the -6th. Again, raising an exponential expression to another exponent, we multiply those exponents. So b to the 5th to the 3rd is going to be b to what power?
15.
The 15th.
Oh, I see where
Because it's both.
Yeah, I just start flopping things.
Oh yeah, don't do that.
Yeah. And now I see you're going to combine both of them.
Yeah, we'll put them all together first.
Okay. That makes
So then c to the -12. I mean, in reality, the order that you like go through these questions doesn't actually matter because it's all multiplication and division. So like you could start flopping things in that first set of parentheses before you apply the exponent. Like sometimes it might be more efficient to do them in a different order, but you'll end up with the same result.
Oh, you will?
Yeah, like if we had rewritten everything with a positive exponent inside the parentheses first, like we would have gotten the same thing in the end.
Okay.
However, because there's a negative exponent outside and because we're going to have to combine the two, we could end up having to like flip-flop multiple times,
Okay.
which is why I just wait until the end to do
that
it.
makes sense, yeah. Okay.
So then my second set of parentheses, -3 times -4 is +12. c to the 4th to the -4th, that's c to the -16th and then I have negative 3 to the negative 4th, and we all wrote exactly that, right?
Yes.
Sure.
And then b to the negative 8th. So now I'm going to make one big fraction.
Why wouldn't we keep the parentheses around each of our division problems?
I mean, you could, but we're going to have to combine them into one fraction anyway. So, like, even if I wrote this, my next step would still be exactly the same, which would be to combine them into a single fraction. Because there's no addition or subtraction to, like, distribute over. So we're really just smushing the two fractions together into a single fraction because we're multiplying them. So our next step is to deal with multiplication and division of the same, of exponential expressions with the same base. So the first thing I see is that I've got a to the negative 6 times a to the 12th. Those are both in the numerator, so I'm adding the exponents. Yep, so that's a to the positive 6th. Then I see that I've got b to the 15th on the top and b to the negative 8th on the bottom. So what should I do with those exponents?
You would take 8 from 15 and leave it at the top.
So we would subtract the exponents, right? Now you have to be very, very careful with this because 15 minus negative 8 is not 7. It is 23. The exponent on the bottom is negative 8. We are subtracting it. No. 15 minus positive 8 is 7. 15 minus negative 8 is 23. If you had b to the 15th over b to the 8th, that would be b to the 15 minus 8, which is b to the 7th. We have b to the 15th over b to the negative 8th, which is b to the 15 minus negative 8. When you divide exponential expressions, you subtract the exponents. Right? Well, but I mean, you know how to, like, the exponent's negative 8, right? And we're going to subtract it. So that's b to the 23rd. And then let's look at our c's. So on the top we have c to the negative 16th. On the bottom we have c to the negative 12th. So negative 16. And it really helps to just write it like over on the side, just to see it, because it's very tempting to do things that aren't actually true. So negative 16 minus negative 12 is what?
Negative 4.
It is negative 4. Well, because this is the same as negative 16 plus 12, yeah? If you're $16 in debt and then you get $12, you are only $4 in debt. So this is c to the, what did I say, negative 4? And then we also have this negative 3 to the negative 4th on the bottom. Remember that when you do the quotient rule, the result always goes on the top. You will deal with the fact that you might have like a negative exponent and that brings it down to the bottom. You can deal with that later. But if you try to combine those two, you end up just with a positive exponent in the wrong place. So do the subtraction, subtract the top one minus the bottom one, and then put the result on the top, and then deal with the sign of the exponent in the next step. So we did 15 minus negative 8, got positive 23 on top, and then we did negative 16 minus negative 12, got negative 4 on the top. And now we will deal with those negative exponents. So negative 1 to the 3rd, does it have a negative exponent or a positive exponent?
Positive.
positive, so it stays on the top. A to the 6th has a positive exponent. B to the 23rd has a positive exponent. C to the negative 4th, it has a negative exponent, so it comes down to the bottom with a positive exponent. And then I have negative 3 to the negative 4th, which has a negative exponent, so it is negative 3 to the positive 4th on the top. What is negative 1 to the positive 3rd power? It is negative 1, right? So we're going to write this as negative . The only time I care about you thinking about what we just said is if the base is negative 1. Like, I expect you to know what you get when you multiply negative 1 by itself repeatedly, because it's either a positive 1 or negative 1. Does that make sense? Like, you don't have to multiply negative 3 times negative 3 times negative 3. But
it's just the rule of odd or even, right? If it's an odd exponent, it would be...
So if you multiply an odd number of factors of a negative number, you get a negative. If you multiply an even number of negative factors, you get a positive. Yes. Okay, I'm going to give you your homework so you guys can do a couple of these.